Hi everyone, my name is Sanjay Chouhan and welcome to my YouTube channel. Before proceeding further in this NLP series, I want to discuss basics of machine learning and the six terminologies used in machine learning so that even if you're not familiar with machine learning, you'll be able to follow the NLP series. In machine learning, we have these three components. So we have the input data, we have the output data, and we have a model. The input data is fed into the model and it produces some output. So this is the basic flow of a machine learning model. So in training phase, we will have two phase. We'll have training phase, and once we train the model, we'll be able to use the model or we'll be able to infer the model. So once you train the model, you will be productionizing the model, and and in production, if new data comes, you'll get the output for that new data. We have training phase and inference phase or runtime phase. So in training phase, basically you have the input data and output data. You use the input and output data to train a model. So here, the in training phase, the output that we get is a model. And in at the time of inference or runtime, you have the input data and you have the model, and you get the output. So you'll have the trained model, and once the new input comes, you can feed into the model. You'll get the output for the new input that we got. So this is the basic flow of machine learning. I think you will be aware of that. Still, I wanted to discuss. So now let's look into some terminologies. So the inputs are represented with X and Y is used to represent output. So X is the input and Y is the output. So if you see some formula or mathematical expressions related to machine learning, you'll see that X is generally used for input and Y is for output. Let's suppose you have this data set where you are having three columns, height, weight, and gender. And here we are having four person, and for each of the person, we are having height, weight, and gender. Okay, so we are having for four people, we are having this data set, and we have this another column called fitness, where we are having the fitness level of that person. So we'll fit the height, weight, and then gender in the model, and we'll get the fitness from the model. So the height, weight, and then gender are the input to the model, and fitness is the output of the model. So this height, weight, and gender are also called features or IDV. IDV means independent variable. So this will be the input to the model, and then the fitness is the output of the model. So this fitness or output of the model is also called dependent variable or DV or label. And to represent each person, we are having X1, X2, X3, and X4. So X1 represent the first row from the input data, X2 represent the second row from the input data, and so on. To if you want to get the height of the first person, so height is the first feature of this input data, right? So height is the first feature. To get the first feature or the first person, you'll use X11. Or if you want to get the weight for the first person, the representation will be X12. So this is how we represent the input data. And in output, for each person, we are having Y1, Y2, Y3, and Y4. So Y1 is the output corresponding to X1, and Y2 is the output corresponding to X2. So these are the basics of basic expressions or terminologies used in machine learning. In machine learning, mainly we have two different kind of tasks or two different kind of machine learning algorithms. One is classification and another one is regression. If the output belongs to a set of categories, so if the output is belonging to a finite set of categories, then the task is called classification. And if the output belongs to a real number or natural number where we have infinite possibilities, that is called regression task. So here we have represented y belongs to C1, C2, C3. These three are three different categories, and if the y is belongs to a finite set of categories, then it's a classification. And here we have here we have given that y belongs to R. R means real number. So y belongs to a real number. That means we have infinite possibilities. So it's a regression task. If you want to get an understanding from the above example, if the y or the fitness level, right, or we had fitness as the output, if the y there belongs to these two categories, fit or unfit, then it's a classification task because the output is belongs to a finite set of categories, right? And we have two type of classification. Basically, we have binary classification and multi-class classification. In binary, the output is having two choices, right? Here, in this example, we have two choices, fit or unfit. So it's a binary classification. If we had more than two categories here, like fit, unfit, and neutral, then this will be called multi-class classification. And example for the regression task will be if you are not predicting these categories, if you're predicting the BMI based on the above table, then the task will be called regression task because the BMI is going to be a real number. It's going to belong to a real number. So it will be like 11.6, 16.5, and so on. So we have infinite possibilities here. So that's a regression task. So let's look into two more things, Y and Y hat. So Y is the actual output. So whatever we have in the data set is the actual output. And Y hat is the predicted output. Whatever we are getting from the model is predicted output. So in literature, you will see that Y is used to represent the actual output and Y hat is used to represent the predicted output. Let's look into machine learning techniques for both classification and regressions. Here are the few machine learning models that we have. Um, In classification models, we have loss regression, decision tree classifier, random forest classifier, XGBoost classifier, support vector classifier, KNN classifier, and we can also build neural networks for classification. Similarly, in the regression models as well, we have linear regression, decision tree regressor, random forest regressor, XGBoost regressor, then support vector regressor, KNN regressor, and neural networks for regression. So you can find most of the models on SQL, and you can these are neural networks models. So you need to use some PyTorch or TensorFlow library for building the neural network models. You can use the XGBoost classifier from the XGBoost library, and others are present on SQL library only. So now let's look into an example. Let's suppose we have a data set where we have movie review. We have IMDb site, right? So in the IMDb, you can see that there are movies and there are reviews corresponding to each of the movies. And let's suppose we have data sets from IMDb where we have reviews of each of the movies. And we want to classify the reviews into positive or negative sentiment. So here in this example, you can see we have a column called review and another column called sentiment. In the reviews, we are having text where we have reviews like awesome movie, nice story. It's a review from some user. Next review is of it's overhyped. And in the sentiment, we are having positive and negative sentiment. So if you want to use the review to get the sentiment, if you want to build a model where we input the review and as the output we get the sentiment, the reviews needs to be converted to numerical form, right? We won't be able to use the reviews directly as a text. We need to convert them to into some kind of numerical form. And we have seen some techniques to convert reviews, sorry, convert text into numerical form. And the techniques are called text representation or text vectorization. Suppose we used one of the techniques to convert these reviews into some numerical form. So here we have converted them into numerical form. And once we convert them into numerical form, we'll have vector representation for each of the reviews. So this is a vector representation for the first review. And once we have vector representation, that means we'll have multiple columns, right? In the input data set. Now we'll have like here we have seen from this one column of review after text representation, we went to 5 columns of numerical representation. We can use this as an input. So this will be the input. This vector representation will be the input to the machine learning model, and then we'll have the output. And we have converted the output from text to numeric data as well. Basically, we have for positive we have converted to 1, and negative is replaced with 0. So we have the output is 0 and 1. So this is a binary output. And now we can build a machine learning model using this table, using this data. Thanks for watching. The idea here was to get a basic idea of machine learning models